This lesson explains the function of the auxiliary power unit and shows its main components. The first segment describes the purpose of the APU. Next, you learn about the main sections on an APU. Then you look at the main components of the APU. In the next segment, you learn about two different ways of APU bleed air supply. And then we look at the electrical power supply from the APU. Finally, you can answer some exercise questions to see what you have learned. The auxiliary power unit is a small gas turbine engine on the aircraft which supplies pneumatic bleed air and electrical power for the different aircraft systems. This gas turbine engine is often called the APU. It is mainly used on the ground when the aircraft engines are not running. On modern twin-engine aircraft, the APU must also provide bleed air and electrical power in flight. We can split the APU into three main sections: the power section, the bleed section, and the accessory gearbox section. The power section of the APU drives the compressor and the gearbox. See if you can find the power section on the video. The power section drives the APU accessory gearbox section. This gearbox drives all APU accessories like the fuel pump, the oil pumps, the cooling fan, and the AC generator. On very large APUs like this one, you may even find two AC generators on the gearbox. The bleed section of the APU must make sure that sufficient bleed air is supplied to the aircraft pneumatic system. On most modern APUs you will find a separate compressor for this task. This compressor is usually called the load compressor. As on all gas turbine engines, the power section has a compressor, a combustion chamber, and a turbine. The compressor of the power section is mainly used to provide the air for the combustion. It can be either a single-stage or a multiple-stage compressor. On some APUs, this compressor must also provide the bleed air for the aircraft pneumatic system. On APUs, you will usually find centrifugal flow compressors. These compressors have good performance, a long lifetime, and they are resistant against foreign object damage, known as FOD. See if you can find the centrifugal compressors on this video. The combustion chamber of a modern APU is usually an annular type, but on older APUs you may also find can-type combustion chambers. The third main component of the APU power section is the turbine. You will find centrifugal turbines on small APUs, or axial turbines with two or more stages on large APUs. In the next segment, you will learn about two different ways of APU bleed air supply in more detail. The APU must supply sufficient bleed air for the aircraft pneumatic system. The air pressure is usually 30 to 45 psi. There are two different methods of APU bleed air supply. One uses the compressor of the power section, and the other one uses an individual load compressor. See if you can find the individual load compressor. APUs with load compressors are very fuel efficient. This is because the load compressors can be switched off if bleed load is not required by the aircraft. This means that EGT limits are not reached so easily because no air is taken from the combustor. This improves the lifetime of the APU. Here you can see an APU with a load compressor. See if you can answer this question. The air flow into the load compressor is controlled by variable inlet guide vanes. These inlet guide vanes work like a modulating and shut-off valve. They can move into any position between open and closed. This is another advantage because the airflow can be changed on demand from the pneumatic system. You will learn more about this in the APU air system lesson. In the next segment, we look at APU electrical power generation. Another major task of the APU is to provide electrical power as a backup source for the aircraft. This electrical power supply comes from generators which are driven via the APU gearbox. Most APUs have one generator which is the same type as the engine generators. You may also find two generators on very large APUs like this one. Remember what you have learned about aircraft generators and try to answer this question. Engine-driven generators need a constant speed drive to run at a fixed speed. APU generators do not need a constant speed drive because the APU is always controlled to a constant speed by the APU fuel control unit. You have now completed the tutorial part of this lesson. You can check your knowledge with the following exercises.